So we're going to think about limits going to infinity. So what is the limit of this function as x approaches infinity or x approaches negative infinity? And what's great about this is really thinking about the end behavior of our graph. Think about what is x approaching, or sorry, what is our outputs approaching as f goes to negative infinity? As x goes to positive infinity, what is our outputs approaching? And so we've really looked at this before when we've dealt with end behavior. So don't think about this as just one new thing. Think about this as something that we have talked about before here. So it says estimate each limit if it exists. Oh, 1 over x, we know that function. We know that function looks like this, right? We know that graph, 1 over x. And as x goes to positive infinity, our outputs are getting closer and closer to 0. Here's a better drawn graph. That's what we expected. As x goes to a positive infinity, the outputs are getting closer and closer to 0. So just because we understand x going to positive infinity is the end behavior on the right side. Boom, we got it. And there is some algebraic, we can see as those x values get bigger and bigger, the y values get closer and closer to 0. Here, this one looks a little bit more daunting to us. We have x going to a negative infinity first of all, and we've got negative 3 over x squared plus 2. Well, hopefully we kind of have some familiarity of the 1 over x squared function. We know that in general this thing looks kind of like a volcano. On our graph it looks like this. There's 1 over x squared. Now think about the transformations that have happened on this. First of all, negative means we flipped it across the y-axis. It was stretched by a factor of 3 because we can see it was multiplied by 3. But most importantly here, plus 2. So after those transformations, it was flipped, it was stretched, but then it was shifted up 2 units. So it now looks something like this, where we have an asymptote at 2. That's really the kicker here. Remember how that vertical shift always told us about our horizontal asymptote. Let's see what the book's picture looks like. It's pretty much what I had, pretty much there, where we have our horizontal asymptote at 2. And so where's it going? As x approaches a negative infinity, it's getting closer and closer to that asymptote of 2. So we can look at the graph once again. We can get a good idea of what this graph looks like without a graphing calculator. Don't always rely on that technology. See if we can process what these things are looking like. We don't have to have a perfect idea, we just need to have a general idea. We can see this confirms it's getting closer to 2. Here, we want to estimate the limit as x goes to negative infinity for this, and as x goes to positive infinity for this. Now this is a crazy looking function here, e to the x times sine of 3 pi x. And I notice that we have sine of 3 pi x, and just thinking about sine of 3 pi x, well, I know sine oscillates between these values. So when we think about the end behavior for a sine, well, sine's not approaching a certain value, it's oscillating between -1 or +1. Just a regular sine graph. So I would expect some does not existing here. Well, if we graph it, notice as x does get closer and closer to positive infinity, this is actually because it's multiplying by e to the x, our outputs are increasing. As x gets bigger, e to the x is getting bigger, so this has got some growth to it. Well, again, it's oscillating. It's going between two crazy different values. But notice this is modeling that natural growth e to the x in a lot of ways. As x gets lower and lower, as x goes smaller and smaller, this right here is getting closer and closer to 0, which multiplied by anything is giving us outputs closer and closer to 0. So as we approach a negative infinity, this is getting closer and closer to 0. And as we approach a positive infinity, this is diverging. It's oscillating. It's not even oscillating because it's going between bigger and, well, I mean, it is oscillating in a way, but it is going between smaller and larger numbers, just the difference is growing. So this side clearly does not exist. We can see is not converging on a certain value. Over here, we can see because e to the x is getting closer and closer to 0 times anything gives us 0.